Okay, guys, as I was just telling you, this is a pretty simple idea, but sometimes it seems like we have a hard time getting it into our heads, all right? So let's think about function notation. It's a way of naming functions, okay? We've been putting equations into function form, right? Y equals mx plus b. We call that slope-intercept form, but another name for it is function form, okay? Sometimes we have many functions, so we want to give them different names, all right? So the name that we might give a function is f of x, or we may even call it g of x, or h of x, because we have lots of different functions and we want to give them different names so we know which ones we're talking about. Okay? Now, I'm going to explain to you in just a moment what we're talking about here, but let's just read this. In function notation, we write the equation in function form, right? Y equals mx plus b, and replace the y with f of x, or g of x, or h of x. These are all different names that are used for functions, so we can differentiate them. We know which one we're talking about. Which function are we talking about? Okay? This stands for, and I put it in quotations here for you, the function of f. That's what we would say. The function of f, or the function of g, or the function of h. Okay? What h does, what f does, what g does, the function of it. It does not mean f times x. Okay? Please understand that we're not multiplying these two things. This whole thing is a name. This whole thing is a name. Okay? All right, now let's see how this works. All right? Let's look at this first example. I'm going to erase this stuff so it's not in our way. All right? It says let f of x equal negative 3x plus 8. Guys, let me ask you again, just having read the definition, what did f of x take the place of? It took the place of y, right? So really, this is just y equals negative 3x plus 8. Do you agree? Right? We just named it. We just said, hey, this function, this negative 3x plus 8, we're going to call that f of x. All right? We just took the y out and we said this is f of x. All right? Now, it says find f of x when x equals 5. And find x when f of x equals negative 22. Okay, that's fine. That's fine. Remember what this is telling us. First, it says f of x equals, find f of x. So we're going to want to find f of x. What does it equal? When x equals 5. Do you see how I plugged 5 in for the x? Do you see that? Okay, but you know what we also do? Get used to this. Whenever I plug in something for x, I put it in here. The function of 5 is equal to negative 3 times 5 plus 8. So the function of 5 is equal to negative 15 plus 8. So the function of 5 is equal to, what is that, negative 7? Is that right? But look at this. Do you see how it's written as a point? This is the x. But what does this thing over here stand for? It stands for y, doesn't it? So y is equal to negative 7. That's the y. So look at this. 5, negative 7. There's your point right there. That's part of what we like about the function notation, is that it keeps what we plugged in right in front of us. We know we plugged in 5 and we got negative 7. Okay? Liam, quick question. I want us to get used to this because sometimes they're going to tell us f of 3 is equal to 12 and f of 5 is equal to negative 13. Do you see how these are 2 points? Right? So we need to know that this is really 312 and this is really 5, negative 13. Okay? Does that make sense? Okay. Now, here's the other part. There was a B part to this. They said, find x when f of x equals negative 22. All right, well, remember, f of x is equal to negative 3x plus 8, right? But they said, wait, f of x is equal to negative 22. So I'm actually going to replace f of x with negative 22.